In this video, we're going to be looking at how the leading coefficient affects the shape of a parabola. So we've got three parabolas here. We've got y is equal to x squared. That's the parent function of a parabola. Then we've got one that has a 2 out front. We'll see what that does to the parabola. And then one that has a 1/2 out front. And we'll see what that does to the parabola. Okay, so let's graph these things. We've got these tables set up already for us. So if I plug in a -2 into the x squared, it gets squared and becomes a 4. So we get the point -2 comma 4. Okay. If I plugged in a -1, it gets squared and becomes a +1. So that's -1 comma 1. 0 becomes 0. So that's the point 0, 0. Let's see, 1 squared is 1. So that's the point 1, 1. And then 2 gets squared, it becomes 4. That's the point 2, 4. So I plugged in all these numbers and these are my answers and these are the resulting points. Okay, so if I put those on a graph, let's see, -2, 4 is here. -1, 1 is here. 0, 0 is in the middle. 1 comma 1 is here. And 2 comma 4 is here. So the parabola looks like this. This is the parent function of a parabola. And it looks basically like that. Okay. Now, what happens if we put a 2 out front? Well, what's going to happen is that all these y values, these ones that we put in here, are going to get doubled because after we do the square part, they're going to get multiplied by 2. So all these numbers are going to get doubled, okay, the y values only. So they'll grow faster and it'll make it look like it's skinnier and grows faster. Okay, so let's try this. So we put a -2 in there. You square it, it becomes 4, right? But then times 2, so that's 8. So you plug in a -2, you get 8. Notice that the y value got doubled, right? Plug in a -1. -1 gets squared, becomes 1. 1 times 2 is 2. So -1 comma 2, double from that one. Okay. A 0, of course, this whole thing will just zero out. Okay, so that's 0, 0. Plug in a 1. 1 squared is 1 times 2 is 2. So 1 comma 2. And then this one, you square the 2, becomes 4 times 2 is 8. So 2 comma 8. All right, so if I plug those points into the graph here, -2 comma 8, 1, 2, 3, 4, 5, 6, 7, 8 is up here. Okay, -1 comma 2 is here. 0, 0 is in the middle. 1, 2 is there, and then 2, 8 is there. So you can probably kind of see that this parabola is going to be kind of skinnier. It grows faster than this one. Okay, so this one's kind of open up wider. You can see that the y values there are doubled. This one was only here at 1 when we plugged in a -1, but this one's at 2. This one was at 4 right here, but this one went all the way up to 8. So you can see that it's skinnier. All right, so let's look at the last one. So if I put a 1/2 out front, what's going to happen? Well, all these y values are going to get cut in half, and that's going to make it look like it's not growing as fast. It's going to make it look like it's wider. Okay, so we plug in a -2. It gets squared and becomes 4. All right, this is 4, but then it gets multiplied by 1/2. It's 2. So -2 comma 2. Okay, notice it is half the y value of the original one. Right, we plugged in a 2 in the original, it was 4, but now we only get 2. That's because our answer got multiplied by 1/2. Okay, we plug in a -1, it gets squared, becomes 1, and then 1 times 1/2 is just 1/2. 0, we plug in that, and we get a 0. Okay, and then -1, or our +1 squared is 1 times 1/2 is 1/2. So that's 1 comma 1/2. And then plug in a 2. 2 gets squared. That's 4 times 1/2 is 2. Okay, so let's plot those points. -2 comma 2 is here. Okay, -1 comma 1/2. -1 comma 1/2 is in between here, right there. 0, 0 is in the middle. 1 and then 1/2 is there. And then 2 comma 2 is there. So you can kind of see that this graph is wider. Try to make it look. So it will go up, but it will be much wider than these other two. Okay, so what's going to happen is that if the number is bigger than 1 that's out front, it's going to look skinnier. The bigger the number, the skinnier it's going to look, okay, or the narrower it's going to look. So if this was a 3, it would be even more narrow. If it was a 5, it'd be even more narrow. Okay, so the bigger the number, the more narrow it's going to be. If the number is between 0 and 1, like 1/2 or 1/3 or 2/3 or 1/4 or all those numbers, then it's going to be wider. And the closer that number is to 0, the wider it will be. So 1/5 would be wider than 1/2. 1/10 would be even wider. 1/100 would be even wider. Okay. And the last thing that you need to know before we start these is that if there's a negative sign, it flips it upside down. It makes it negative, but it does not change how wide or skinny or narrow or wide this thing is. All right, so let's look at these questions. We've got 4 functions here. They're all parabolas. The first question says, for each parabola, choose whether it opens upward or downward. So, like we said, the only reason it would open downward is because it's got a negative sign in front of it. So that one opens downward. The rest of these are up. They open upward because they're positive. Okay. Now the narrowest graph, and the sign doesn't matter. We're only looking at the narrowest graph. Okay. So that is going to be the one with the biggest number in front. Okay. And the sign doesn't matter. So you've got this 3 and this 4 here. The bigger number is 4. So this will be your narrowest graph. Okay. And now for this question, we've got choose parabola with the widest graph. That's going to be the number that's closest to 0. Okay, so you've got this 1/3 and 1/4. Which one is smaller out of 1/3 and 1/4? This one. Okay, so that one's going to be our widest graph. 1/4 is smaller than 1/3. Okay, let's take a look at the next one. So we've got 4 more here. It's asking us again, are we opening upward or downward? The only reason you would be opening downward is if you have a negative sign out front. So this one opens downward, this one opens downward, and this one opens downward. Okay, this one is positive, so it opens up. Okay, okay, choose the graph with the parabola with the widest graph. Widest means it's a small number, it's close to 0. Okay, close to 0. So we've got these 2. Okay, these 2 right here that we're choosing from. The sign doesn't matter. We're looking for the widest graph. Okay, so we will choose the 1/4 because that is a smaller number than 1/3. So widest graph is there. Narrowest graph will be the one with a big number, biggest number in front. The sign doesn't matter. So 1/4, 3, 1, 1/3. So the 3 is the one. That's going to be the narrowest graph. It's going to grow the fastest. Okay, let's take a look at a few more. Okay, this time we have the graphs and not the functions. So we're going to get asked questions about these graphs. So first, for each coefficient, choose whether it is positive or negative. Okay, so if it's got a negative coefficient in front, it's opening downward. If it doesn't, then it's opening upward. So the ones that are opening downward have a negative coefficient. Okay, so we'll say negative, and negative. And this one is positive because it opens up, and this one is positive because it opens up. Okay, now choose the coefficient that's closest to 0. So if it's the closer it is to 0, the wider it's going to be. Okay, so this is the widest. That's what you're looking for here, the widest graph, and the sign doesn't matter. So it looks like this one right here is the widest graph. That is C. Okay, choose the coefficient with the greatest value. Now this one is a tricky one because sign matters. Sign matters on this. If it says greatest value, positive numbers are greater value than negative numbers. Okay, so you got to keep that in mind. If you're looking for greatest value and you have positive graphs like these 2, it's going to be between those 2. Okay, these are negative graphs, so they won't have the greatest value. So between these 2, which one is greater? Well, remember that the bigger the number, the skinnier the graph, right? So this is the skinniest graph, so that has the greatest value. Okay, last set of questions here. Okay, so we have these graphs. Choose whether the coefficient is positive or negative. Okay, if positive if it's opening up, it's negative if it's opening down. Okay, so this one is positive, this one is negative, This one is negative, and this one is positive. Okay? Choose the coefficient closest to 0. Okay, again, that is the widest graph. The widest graph out of all these, and it doesn't matter if it's opening upward or downward. So this one is the widest graph. Okay, so C is our answer. Okay, and then the coefficient with the least value, sign matters. The sign matters on this. Okay, so if it's least value and you have negative graphs, you need to use those. Okay, because these are going to be positive. So positive numbers are more than negative numbers. So the least value is going to be amongst these two. Okay. And you're looking for the biggest negative number you can find, right? Because big negative numbers are less than small negative numbers, right? Negative 1 million is definitely less than negative 1, right? So you want to choose the biggest number out of these two. And we know that the skinnier the graph, the bigger the number. So this is the one you're looking for right there. And your answer is B. And that's it.